All right, class, welcome back to geometry, the unit right triangles and trig. We're going to get into special right triangles today, and we're going to have fun because it's really all about shortcuts. So I'm going to do, again, some split videos and try to make them a bit more manageable. This is everything we're going to learn about special right triangles, the old 45-45-90, the 30-60-90, and then finding all the other details of a triangle given those two special triangles. But in the first video, I'm going to focus only on the 45-45-90 triangle. So let's take a look and see what this special triangle is all about, because it's kind of a cool shortcut. So we have a theorem, whoop-de-doo, but it's about the 45-45-90 degree right triangle. So how do we know we're dealing with a 45-45-90? Well, clearly we have a right triangle, right? A right angle. And if one of the angles is 45, well, the other one must also be 45 due to the interior angle sum theorem for triangles. So if that's the case, okay, if we have a 45-45-90 right triangle, we have some interesting length shortcuts to know that it's just short of the Pythagorean theorem. So we can just use shortcuts real quick. Both the legs are congruent, right, because we're dealing with basically half of a square. So both the legs are congruent. And the hypotenuse turns out to be the length of the leg times the square root of 2. And that is the shortcut of the 45-45-90 right triangle. And you might be thinking, well, that's pretty easy. Well, you might not. It can be easy, but you have to have some practice with it. This might be a little bit confusing to look at. So what I'm going to do is give you a couple other situations where that's the case. So here's the deal, like my own drawing, right? So we have a 45-45-90 right triangle. If the legs are each 1, the hypotenuse is 1 times the square root of 2. That's the Pythagorean theorem at work, right? The sum of the squares of the legs equal to the square of the hypotenuse. So if you have a leg length of 1, another leg length of 1, the hypotenuse is the square root of 2. So that is the 45-45-90 triangle. Still not convinced? No. Well, let's do another example. So here's another 45-45-90 right triangle with a smudge. So right angle, 45 degrees. This one must be 45 degrees. 3 is the length of a leg. So what's the other leg, right? The other leg is going to be 3. Whoa, not that. Cats, pay attention. The other leg is going to be 3. Let's scratch out the whole thing. So the other leg is going to be 3. And then the hypotenuse then is going to be 3 times the square root of 2. That is the length of the hypotenuse. It's the hypotenuse is the length of the leg times the square root of 2, right? So you see that little note? Square root of 2 times the leg. So the length of the leg times the square root of 2. The length of the leg times the square root of 2. The length of the leg times the square root of 2. Okay, that is the shortcut for the 45-45-90 right triangle. So now let's go a little bit backwards. Take a look at this last little picture that I drew. Here we have, again, a 45-45-90 right triangle. I give you the hypotenuse as 7 times the square root of 2. So what must the length of the legs be? Now, if in the 45-45-90 the hypotenuse is the square root of 2 times the leg, and look at this particular hypotenuse, then that means the leg must have been 7 units each. Okay, so 7 units each. So we can now find the length of the other legs using these shortcuts. And that is the first of the special right triangles. So let's do some work. This video is only about the 45-45-90 right triangle. So let's do some work with that, okay? Okay. So here's the first example. We have, of course, a 45-45-90 right triangle. The question is, what is the value of the variable? Okay, well, what are we given? We're given 9, and 9 is it a leg or the hypotenuse? 9 is the leg. So what does that mean for the hypotenuse? The hypotenuse, being across with a 90-degree angle, bloop, 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 hypotenuse. The hypotenuse is going to be 9 times the square root of 2. And ladies and gentlemen, that is it. Seriously, that is it for the shortcut in the 45-45-90 right triangle. Not convinced? Let's do another example. So here we have another 45-45-90 right triangle. The question is, what's the value of the variable? Of course, this is the hypotenuse. So what's going on? 2 times the square root of 2. This is not the hypotenuse. This is the leg, dudes. Pay attention. This is the leg. Okay? The hypotenuse is across from the 90-degree angle. X is the hypotenuse. So don't let that scare you. Okay, that's like a tricky little thing, but you're better than that. Don't let that fool you. That's a leg. So what then would be the hypotenuse? The hypotenuse then would be 2 times the square root of 2, which is the leg, but then that times the square root of 2. That is the hypotenuse. Okay, so this is what our hypotenuse would be. All right, but now you're thinking, Mr. Katz, what is that? Well, we got to remember some neat tricks. What are we looking at? We're looking at 2. This, of course, is the number 2. 1, 2, 2. This is the square root of 2 times the square root of 2. If you didn't know, the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. So do we even need that little step there? No, dude, shortcut. The square root of 2 times the square root of 2 is 2. So this 2 is 2. The square root of 2 times the square root of 2 is another 2. Guess what that makes the hypotenuse? That makes the hypotenuse 4 units. Okay, so that's how we find the missing variable. We have to know a few things with radicals. I'll show you some more in a bit. Another example. Okay, so here's the question. We have what is the length of the hypotenuse of a 45, 45, 90 triangle with a leg length 5 root 3? Okay, so what's going on? If you don't know, draw a freaking picture. So picture, bloop, bloop, picture. Right angle, 45, 45, 90. Okay, so there's our picture. And it says, all right, the leg length is 5 root 3. So let's go ahead and label one of the legs 5 root 3. What then is the hypotenuse? What is the length of the hypotenuse? So that's the question we're asking is this. So we have our leg, and we're going to take our leg, 5 root 3, and we're going to multiply it by the square root of 2. Okay, so hopefully you know some basic algebra. If not, buckle up and understand what's going to happen. The square root of 3 times the square root of 2 is the square root of 6. The square root of 3 times the square root of 2 is the square root of 6. So we have 5 times the square root of 6. And guess what that is? That's our hypotenuse. So what is the hypotenuse? 5 root 6. Piece of cake, man. All right, so that's the 45, 45, 90 triangle in action. But wait, there's more. Really? Really? So here's another question. Now what we're going to do is find the value of a leg. So take a look at this diagram. Now we have the hypotenuse. Okay, the hypotenuse is 6. The question is, what's the length of that leg? So how did we get to the hypotenuse? Well, remember, the hypotenuse is the leg times the square root of 2. So in this case, we have x times the square root of 2 would give us the hypotenuse. Okay, so this length times the square root of 2 gives us the hypotenuse. So then what is the value of the leg? Well, clearly we divide both sides by the square root of 2. Okay, so x is 6 divided by the square root of 2. I'm not going to circle that answer because we have to learn a thing. Note. Something called rationalizing the denominator. This is a very, very important thing. We can't divide by an irrational number. So when we get to trig and you start seeing something divided by pi, question that. Anyway, how do we rationalize the denominator? We have to make the denominator a rational number. How? We multiply by a clever 1. Now, what does that mean, Mr. Katz? You and your clever 1. I don't understand what that means. Well, let's remember some stuff. So a couple of things we have to take note of. The first thing is this. The square root of 37 times the square root of 37. Remember that shortcut I talked about earlier? Here it is again. The square root of 37 times the square root of 37 is 37, right? That's a neat shortcut to know. So what does that have to do with a clever 1? Well, remember also that the square root of 37 divided by the square root of 37, square root of 37 divided by square root of 37 is equal to 1. That's a clever 1. So what does that have to do with rationalizing the denominator? Remember where we left off in this particular example. We had 6 divided by the square root of 2. We have an irrational denominator, and we must rationalize it. How? We're going to multiply by a clever 1. So what would be a clever 1 that would turn this denominator into a rational number? If you take this note and you turn your brain on for a second, hopefully you realize The clever one is going to be the square root of 2 over the square root of 2. This is the number 1, okay? So all we're going to do is multiply by 1. But what does that do to the denominator? Well, remember this note. The square root of 37 times square root of 37. What do you think the square root of 2 times the square root of 2 is? Just 2. That means we will have a rational denominator. That is a huge deal. So when we multiply, we have 6 times the square root of 2 divided by 2. Look at your numerator. 6 times the square root of 2, 6 times the square root of 2, divided by 2. Okay? But wait, there's more. What's going on here? We have a 6 in the numerator, a 2 in the denominator. Guess what we can do? We can divide. So we can divide to get 3 times the square root of 2. Now, if that was confusing, you need to rewind and watch the whole thing again. Make sure you understand what's happening. So when we have this problem here that we were talking about, we had x equals 6 over the square root of 2. Well, remember, we have to rationalize the denominator. So it's going to be 6 root 2 over 2. And then 6 divided by 2 is 3. So x is then 3 times the square root of 2. That is the length of our leg. Okay, and just to check, if we multiply that by the square root of 2, we'll end up with 6. Okay, so that's how that works. It's going to require practice. Speaking of, let's do it. Here's another question. The length of the hypotenuse of a 45, 45, 90 right triangle is 10. What's the length of one of the legs? So let's draw the picture. Okay, we have 45, 45, 90. Boom. Boom. There's my 45. The length of the hypotenuse now is 10. So now we are given the hypotenuse is 10. What is the length of a leg? Okay, so that's the question. Well, in order to get to the hypotenuse of 10, we multiplied that leg times the square root of 2. So the leg times the square root of 2 would be equal to 10, right? That's what the situation is. So in order to find the missing value, we're going to divide both sides by the square root of 2. Was root of 2, right? So our missing leg is 10 over the square root of 2. But we can't do it. That's impossible. We can't have an irrational number in the denominator. You can't separate things into an irrational number of groups. So that's a no-no. So what do? We have to think of the clever one, which is going to be the same clever one we did in the previous example. So if we multiply 10 over the square root of 2 times 1, in this case, the square root of 2 over the square root of 2, we can then rationalize our denominator. Okay? So in the numerator, we have 10 root 2. In the denominator, we have 2. Okay? But what's happening? In the numerator, we have 10 times the square root of 2. In the denominator, we have 2. So 10 divided by 2, we have 5. So our missing leg is 5 times the square root of 2. And again, if that was confusing, now is the great time to pause and rewind and do it again until you completely understand it inside and out what was happening. Okay? A couple more examples, we'll call it a day. Finding a distance now. Okay? Yay, baseball. Or softball. So here's the word problem. High school diamond is square. Giddy up. There's our square. The distance from base to base is 60 feet. To the nearest foot, how far does the catcher throw from home plate to second base? Okay, so the question is, we're looking for the length of D. How far does the catcher throw? Well, hopefully you see that we have a leg of 60, right? So the leg is 60. The hypotenuse then is 60 times the square root of 2. But you got to be careful. It said to the nearest foot. So what do? We use a handy-dandy calculator. Woot! So we'll turn the calculator on. We'll take 60 times the square root of 2. So 2 square root. By the way, most skilled laborers know this number, 1.4. But that's another story for another time. So if I multiply those together, I have this number, 84.85281374. The question said to the nearest foot. So we're rounding to the nearest 1. So 84.8 turns out to be 85 feet. So if we are rounding to the nearest foot, it's 85 feet. Okay, so sometimes we use our handy-dandy calculator and we'll figure that out. All right, great. Another example. You plan to build a path along one diagonal of a 100-foot by 100-foot square garden. Do you? Do you plan to do that? Well, just in case you do, this is a great word problem. So we have a square garden, and it's 100 foot by 100 foot, and we're going to plan to build a path along the diagonal. Ooh, right? To the nearest foot, how long will the path be? So here we go again. To the nearest foot, how long will the path be? So if we have a 45, 45, 90 right triangle, how do I know this is a 45, 45, 90? Because it's a square, and the diagonals bisect the angle. Half of 90 is 45. This is a 45, 45, 90 right triangle. Yeah, buddy. Did you see that? It's a square. Diagonals bisect. Half of 90 is 45, 45, 45, 90. Therefore, the diagonal is 100 times the square root of 2. And by the way, this is the reason why most skilled laborers know the number 1.4, because it's across a square, right? You ever see tile cutters and carpenters and all that stuff? Anyway, so 100 times the square root of 2 equals 141.42. But the question is, to the nearest foot. So we're going to do some roundage. To the nearest foot. To the nearest foot, 141.4. That ain't enough to bring it up to 142, so it stays 141 feet. And that is how we use the 45, 45, 90 right triangle. I hope you enjoyed this lesson. Come back again for the 30, 60, 90, and we're going to have some fun. Peace.